My presentation will be related to inclusion and e-learning. I will start with problem statement and inclusion definition, and I will finish with results and some conclusions. What is inclusion? I think that you know that inclusion aims to reduce the gap in ICT usage and to promote ICT meaningful use of ICT. But as we can see from Bureau statistics, the situation today not so good. Most of individuals have basic digital skills, but the problem is meaningful use of ICT. And my topic will be related to this meaningful use of ICT. The general focus of our study is to develop a technological model for prediction of e-inclusion for individuals. But and we are based on knowledge creating and knowledge transfer of individuals. But today, and research questions are two. The first is what methods to determine the degree of inclusion for individuals. And the second research question relates to technology and methods for predicting this inclusion degree. But today I will tell about two tasks that we were completed. This task relates to analysis of trends in inclusion today and relates to technologies and for prediction of inclusion. Okay, the first task was to analyze overall situation in the field of inclusion, and the main results that I would like to stress are following. That today, target group for inclusion is not only unemployed people or people living in remote geographical areas or bad economical areas. Today, focus shift to young people, also next employees who should actively use ICT in everyday life. For example, teachers who should follow for changes in ICT. And also, second result is that not only digital skills are necessary for inclusion, but we should provide that people know how to use these digital skills for their job, for studies, and we call this meaningful use of ICT. And the third result was we found that today mostly authors or researchers analyze inclusion by demographical factors or economical factors of individuals, but these factors we can't change. We can't change the age of person, or we can't, it's hard to change their place of living, but we try to look to individuals by means of knowledge management theory. Next version, we are two methods and technologies. We have research based more than 700 professional education teachers. They learned e-learning course and they developed, they improved their digital skills. And we have two main challenges. We try to identify factors which predict the inclusion level of individual, and also we try to find methods or algorithms which we can use for prediction of the inclusion. As I mentioned, we use knowledge management theory based on research Nissan, who stated that knowing doing that instead from problems with knowledge flow. And for knowledge to flow into individual level, the instructor must be willing and able to share knowledge, and the student must be able and willing to learn. And the second statement of Nissan relates to famous Newton law. That is force equal mass times acceleration, and Nissan states that the teacher may represent the force, but a single chunk of knowledge may represent the data. And we developed this theoretical model based on the Nissan theory, and we choose two factors for prediction level of inclusion for individuals, and this, the first factor is the degree in which instructor will be able, is willing and able to share knowledge. Also, we add the quality of e-learning environment and the quality of e-learning material. And the second factor relates to the degree in which students are willing to learn and able to learn. And the second was the theoretical model related to the second statement of Nissan. This relates that knowledge flow acceleration we can calculate by force and knowledge mass. And no results. The first results were related to we observe that there are no statistical significant correlation between predicted usage of newly acquired digital skills and observed usage. Students are very optimistic in future usage of digital skills, but as we can see in this diagram, blue line is predicted usage of digital skills and this red line is real observed usage. Of course, mostly students predict but not use this in real life as digital skills. This second slide shows us that we divide students in clusters. For example, blue line, students which don't use at all, newly learned digital skills, and yellow and green, students which learn which use it after course digital skills. And we analyze several attributes of students, and as you can see that values of attributes differs for different clusters. And one more slide about linear regression acquisitions. We can calculate this inclusion level by using linear regression acquisitions for all learning course topics. But as you can see, these acquisitions are different for different topics. And this is for knowledge flow acceleration. And these linear regressions are for other variables. And the main results are that we can predict this inclusion level by students' self-evaluation of e-learning materials, e-learning environment, and student willingness to learn, student ability to learn. And now I would like to present some conclusions. We concluded that linear regression as a method is usable for predicting e-learning, inclusion, and we determined some predictors as knowledge flow acceleration and others. For example, instructor willingness to share knowledge, student satisfaction with e-learning data, and so on. Also, we concluded that cluster analysis also is usable method for inclusion prediction. Also, we determined some variables or attributes. The main conclusions are following: that it's not possible to calculate only one linear regression acquisition for all e-learning topics. We concluded that that these linear regressions are different for different topics. And if we are planning to develop technical model of inclusion prediction, that we take into account that this model could be limited in each course topic. This model should be dynamic intelligent agent approach, or inclusion prediction or technical solution. Thank you.